While it's possible for EF-Core to run raw SQL queries as you just saw, more often I prefer to keep raw SQL out of my code and instead store it in the database in the forms of stored procedures, views, and other database objects. But in the cases where it's not possible to do that, expressing your own queries in raw SQL is a really useful option. With a stored procedure in the database, you can still use the raw SQL query methods to execute those procedures and return entities. I want to show you that next. However, I don't have any stored procedures in my database yet. So that's the goal we're aimed at right now. Well, there are various ways to add database objects to a database. I want to show you how it's possible to use migrations for this task, since we're already using migrations for other schema changes to the database. If you're working with a team that's already using EF-Core migrations to keep everyone's development databases up to date, or even for the production database, it's important to keep the workflow consistent. And you can incorporate the creation of database objects or other schema changes you need to apply into your migrations. I'll show you how to do that with this stored procedure. But first we need to figure out what the stored procedure will be. And I want one that will allow me to get a list of authors who published any books within a range of years. So instead of having to write a LINQ query to do that, I can call the procedure and pass in that start and end year I'm looking for. To prepare for this, my workflow is that I work out the query directly against the database, and then I create a stored procedure based on that. I won't waste your time with that part of the process, but here's the command I've arrived at to create my procedure named authors published in year range. Originally, I had forgotten to use the distinct clause, but seeing the results while I was testing made me realize I would get duplicate authors for any who had multiple books in that range, and the change checker would not have liked that. So this pre-testing is very helpful. I'm declaring the incoming parameters, year start and year end, and those are integers, not dates, because I just want to pass in the year number, such as 1984 or 2022. Then the query selects all of the columns from author, left joins to the books on the matching author IDs, and then compares to the start and end parameters. I'll run this create procedure command to make sure it correctly creates the stored procedure in the database, which it does. And then finally, I'll execute the procedure passing in the values 2010 and 2015 for the parameters. And I am getting the results I expected because I know in my data there are only 2 authors that published books in that range. So I know that my create procedure command is working. Now I'll drop that procedure from the database and you can see it's gone. You might be wondering why I didn't just leave it there and skip the whole business of creating the migration. If I did that, then nobody else on my team will get that stored procedure in their development database. By creating the migration, it will be part of our shared source code. And then when other team members pull that source, their own development databases will get updated accordingly. The migrations can also be leveraged in other environments, for example, CI/CD or testing, and depending on your workflow, even production. Now that I've done all that preparation and testing, I can go ahead and create my migration with confidence. It's possible to create a migration even if you haven't made any schema changes to your data model, and that's what I'll do. I'll run the add migration command, and I'll call it add stored proc. And there's a new migration file with an empty up and an empty down method. They're empty because it didn't discover any changes in the data model. The Migrations API has a method called SQL that lets you pass in raw SQL for it to run against the database. So I'll add migrationsbuilder.sql. Code completion helps me by preparing for a string literal. That's the ampersand before the quotes, which, if you haven't used it before, allows for line wrapping strings in code. And that will make the SQL much more readable. I've already copied the SQL for the stored procedure, so I'll just paste it in here and clean up the formatting a bit more and then add a semicolon at the end of the parameter. Don't forget about the down method. If we need to revert the migration, it needs to know to drop the procedure I just created. So I'm adding another SQL method, and in there I'm calling drop procedure with my procedure name. Okay, now I can go ahead and update the database with this new migration. And when I refresh the database in SQL Server Object Explorer, the stored procedure is back. Now we can move on to see how to use EF-Core's raw SQL methods to call this stored procedure. Now that we've got a stored procedure for querying in the database, I can show you how to use the raw SQL methods to query using stored procedures. This is possible with either of those methods. You can use from SQL raw with a formatted string or from SQL with an interpolated string, just like we did in the earlier queries. Both of these methods allow you to pass in any parameters expected by the procedure, and EF-Core will know how to pass those along to the database in the manner that it expects. These are the most common uses, and you can find more examples in the EF-Core docs. But keep in mind that stored procedures aren't composable. Therefore, you can't compose on top of these in the same way you can with the SQL expressions you saw earlier. So you can't eager load with include or use other link methods like sorting and filtering. In some scenarios, it will appear to work, but what's happening there is that the procedure is being executed on the server, and then the rest of the work is being performed in memory. And if that's happening unintentionally, it can cause unexpected side effects, especially with performance. My author's published in year range procedure expects two integer parameters, the beginning and end year of the range you want to filter on. In my first method, I'm using from SQL raw and a formatted string. The string starts with a procedure name, author's published in year range, followed by two placeholders, 0 and 1, in curly braces. And then after the string, I list the two year values, 2010 and 2015, and the string and parameters are all separated by commas. Notice that I didn't use the exec statement in the string. This will work with or without using the execute, so I've skipped it. The next method is using interpolation. And remember, for both formatted or interpolated strings, you can use values for the parameters like I did with the previous query, or you can use expressions. So this time, I'll create start and end variables for the start and end years. Then remember, when I create the string parameter for from SQL, I need the $sign before the string, and instead of the placeholders, I just put the variables start and end into the curly braces. And here's the result of the first query. I have the two authors that I expected to get returned. And in the log, here are the two parameters that got passed in, and then it's calling the procedure. The interpolated string works exactly the same. I get the same pair of authors because the same command with the same parameters was sent to the database. And don't forget that one of the rules for raw SQL methods is that your SQL or the stored procedure can't return shaped data. And again, unlike using SQL expressions, with stored procedures, you can't get around that with the include method. And remember the other rules that we learned about these methods. Because I'm querying from the author's DB set, the shape of the result of the procedure must match the author type, not just in the properties, but also the column names need to match the property names. That way, EF-Core will know how to create the resulting objects. Also note that if EF-Core isn't able to figure out the SQL that you've passed into any of these methods, you'll get an exception at runtime. The compiler will not be able to figure that out. And don't forget to check the documentation for additional guidance on using these raw SQL methods. I've been looking forward to showing you the new SQL query feature that lets you query for types that aren't represented by mapped entities. SQL query is a method of the database property of dbContext. It's generic because you need to let it know what type is being returned. The parameter takes a SQL expression, and that creates a query, so you still have to trigger execution with a method like toList. Whether you're returning scalar data or objects, you can use SQL query with an interpolated string or SQL query raw with a regular or formatted string. The benefits are the same here as they are with the dbset from SQL and from SQL raw methods, including the fact that you can write queries against tables and views or execute stored procedures. Let's start with some scalar query examples. In this first method, I'm specifying that the return type should be an int, and I'm passing in SQL to select author ID from authors. Easy peasy. Next, I'm expecting a string, and I'm querying for the titles of all the books. The third query is one where I'm composing on top of the query. Notice that I'm naming the title result column as value. The way that EF Core builds the queries, it does the same. So if you don't emulate that here, then the composition won't work and you'll get a runtime error. Let's look at these and a few more in code. After the book query with a filter that I already showed you, I have another one that's commented out. And I just wanted to be sure that you see you can't make up any filter that you want when composing. EF Core needs to be able to translate it into SQL, and it just can't translate T length. So instead, in the next query, I'm using an interpolated string to filter on the length right in the T-SQL. And notice that I'm putting the value 10 in curly braces, so you'll be able to see that the value will be parameterized. The last query uses SQL Query Raw to perform the same query, but instead of the interpolated string, it's a formatted string. After running this method that has all these queries, here are the results. There are my IDs, my titles, and all three versions of my filter titles. And the SQL is as simple as you would expect. And note that yes, the last two queries were indeed parameterized. Let's move on to returning objects, not just scalars. Here are two examples of using SQL Query to return results that will map to a class called authorName. The first is a simple query, and the second is calling a stored procedure. You can do that with scalars as well. But there are a few rules I want to be sure you're aware of, and I'll show you those in code. I'm starting with what looks like the right thing to do. I'm using SQL Query with a query expression. But the compiler is complaining because I haven't expressed a type. And what's the type? Well, it can't be an anonymous type, or this would have been okay. So there needs to be some known type to capture the results into. I've created an author name struct that's just internal to the program class, and now I've specified that the type for the query is author name. Yet it's still complaining, and that's because I'm not using an interpolated string, so I'll toss the $sign in front of the quote. Now the compiler is happy. And I went through this because it's completely normal to forget all these little things as you go along, even for someone who has all the experience that I have. So now I'll run it and, well, there's a runtime error. It's complaining because the type can't be a struct. It has to be a class or a record type. So I'll change it to a class, and now the query executes. I get my 9 author name objects. Before I can demonstrate using a stored procedure, I've defined a new stored procedure called getAuthorNames, and I went down the path I showed you before. I created a new migration and updated the database. And here's proof. There's the procedure in the database. Now I'll create a query using that procedure, and this procedure doesn't happen to need any parameters, but you can do that as well. When I run it, there again are my 9 authors. And looking at the SQL, all EF Core had to do was send the call for the procedure. There's so much more you can do with SQL Query, and personally, I could have fun all day testing a huge variety of things, but it's time to move on. So be sure to check the docs for more info, or just play around with it on your own.